this here I can show you in a more topological change. Why I insist on the name topology and the switching method now? Because I start here with a true converter, active switch, and a diode. And then what is the next step? To get AC line voltage to, not the DC input, AC line voltage to get to the output, what do I need to do? What is the only change? I showed you.
Right. Change the inductor into a diode.
Turn inductor into a diode, right?
And have a bidirectional switch, also known as gallium nitride switch.
Absolutely, absolutely. So here what it is. We have I think I can move this smoother this way, right? So we have here. So eliminate this inductor, replace it with diode in the positive direction. We eliminate this. We replace the direction of the diode in opposite direction. So we have two diodes to generate positive input. And what is the next step?
Add an inductor, the small one, LR.
Yeah. So here is what I was explaining. Positive cycle. See what happens in the positive cycle? I have a red one is charged and the blue one is discharged. Okay. Now what happens for negative cycle? Here. Cool. You see what I'm trying to say? For positive charge, top diode is charging in a PW way, and the bottom diode is in the blue discharging. And what happens when the negative voltage is on input? What happens? Oh, now they change the operation. Negative voltage forces the diode, bottom diode to operate and do what we say charge, but it's charging with the two diodes, change the association, charge versus discharge. Now the bottom diode for negative input is charging the capacitor in opposite direction, but the top diode is discharging. You see what I'm saying? Can you see that now these two diodes are doing what the full bridge is on input, right? Yep. So we don't need a full bridge input, it's a ghost. What's there? Of course, what is going to happen is in this two position, when we are doing this position, or charge positive cycle and the discharge, what is going to be DC voltage on this capacitor? Anybody can tell me? What is the DC voltage on this capacitor?
Which capacitor? C out or C?
No, C. Oh, okay. I call it C and I call it C zero is output. So what is the voltage of C capacitor when the input voltage is positive?
Maybe since it is having a charge balance, so maybe zero.
Not maybe zero. It must be zero.
It must be zero. Yeah.
Okay. And what is on the bottom circuit? This capacitor voltage on the capacitor C when the negative voltage operates.
You have the output voltage. Voltage of the capacitor will be the output voltage.
Output version, exactly. It is equal to the output voltage because in this loop, a discharge loop, when a main switch is shorted, then you have discharge, blue discharge, and blue discharge is putting this capacitor, which is minus plus, in parallel with the output, so it's basically equal to the output capacitor. So now you can say, oh, for a positive cycle, this capacitor, applying capacitor, is, and then only the sine wave, 60 hertz sine wave, then this capacitor changes to output voltage. Right. Well, does it any matter? No, well, this capacitor is allowed to do whatever is dictated by the rest of the circuit. So yeah, during that zero transition from this sine wave changes from positive cycle to negative cycle, this capacitor will change, polarity, change not only polarity, but it will change also voltage. This was zero voltage and the other one will DC. But it's inside converter. Converter doesn't see how output is actually doing what it's supposed to do. So really, now you have, and I introduced this way back then. You can see, I think now in 2011, I published a sequence of the 4 papers from June till December that year in the Power Electronics Technology magazine, which was at that time print edition. And then there is this, I said 4 articles. I introduced the power factor correction there, and then all the demonstrations of and here it is some summary of that. Here is this is actually non-isolated version. Operate the power factor correction. Input voltage comes to 10 volts, and total harmonic distortion 1.7%, and power factor is perfect, almost 0.999, right? And then isolation is the same version. Just put a transformer in between, and then you get this this version. Okay, so we've done that. And the transformer is full flux balance, no air gap, no energy storage, automatic reset, and scalable to high power. So there's no power limitation. In fact, the only power limitation in this circuit is what? The boost inductor input, because that has still the DC bias. But other than that, everything is scalable in power. And by the way, remember I told you, boost inductor or buck inductor compared in this converter to the transformer has a 2 core sizes down compared to the 2 core sizes. Transformer is 2 core sizes smaller than the inductor. So the biggest size is really in that inductor. So that's what I worked after that, how to eliminate even that inductor and then make a still isolation and power factor correction by having only 2 AC transformer and no storage. Okay, and that can be done. All right, so this is a demonstration that I made originally, and you can see here on the scope, you don't see sine wave. And I was advertising the sine wave power factor correction will be that current is in phase with the voltage, so the voltage is sine wave, current will be in the sine wave. But you see current here is in the blue. And why it is not the sine wave? Because utility line is not sine wave voltage. Utility line is bad because everybody uses just a bridge rectifier to rectify and conduct it onto the peak of the sine wave voltage and carry more current, and that distorts the line. So this here flat part is distorted because everybody is using cheap rectifier to get the power factor line. Okay, but actually, what it shows that the converter does what it's supposed to. Power factor correction means current is proportional to voltage. You see the same distortion you have in the voltage is shown in the current. But we proved way back when we were doing it with Professor Little, we can publish some papers, but we showed that actually unity power factor, you don't want to generate sine wave current if it is distorted line. You want to generate sine wave current, which is the current which is proportional to line, even if it is distorted. So anyway, that is what it then. The point is, if you do unity power factor correction, making the sine wave, making the current proportional to input voltage, even if the input voltage is distorted, then your power factor correction circuit will tend to improve the line voltage and make it more sinusoidal, believe it or not. Okay, and I don't know why utility companies it'll be so cheap to require that everybody at home. You have now meters that they meter, give you instantaneous time of what you spend on electricity and so on. But it'll be very easy if they install requirements that every household should have a power factor correction circuit and draw the current in phase line and keep operating a unity power factor. Because utility company is hurting actually. Because if you operate with a rectifier and a single phase, you have power factor of 50%, half a power. They have to produce twice as much power to give the same active power, right? So and you pay the same thing if you have a unity power factor. If you don't, the utility should be actually, motivated to install this in all new homes because they'll be saving money. And what they do for a big industrial outfit, they measure their power factor and say, oh, you have a bad power factor of 0.7, you pay 50% more every kilowatt. So but they don't do it for residential. So that's another thing that there's a lot of waste. Okay. Anyway, so we go further down here, and you see here just one comment. You see what happened because the voltage at this instant. This is a moment when the sine wave changes from positive to negative. So you see, it's no idea because this capacitor has to be charged from 0 DC voltage to suddenly DC voltage, which is now equal to the output voltage. But because that's happening at low voltages, this glitch is very little affecting the performance because measurement shows the power factor is still 0.999 and total harmonic distortion is 1.7%. And you can operate on both 110 or 220 lines, so you can get the decent harmonic distortion even for a 220. In other words, you can operate both 110 and 220 and still have this thing operational.